In this video, I'm going to find the limit of a function using L'Hospital rule. And then what I want you guys to understand here is that whenever we want to use L'Hospital rule, that basically means maybe the limit of the function is not divine. You understand? Like it is not divine. For example, let's say we have a function f of x, right? Right? You have function f of x divided by what? G of x. And in this case, after finding the limit, we actually have it to be 0 divided by 0, right? Or we have it to be undefined divided by what? Undefined, right? Or we have it to be, let me simply say n divided by 0. N can be any value. It can be any constant value. Maybe like we have it to be 2 over 0, or we have it to 1 over 0. So whenever we are finding the limit of a function, our mix of direct substitution, we now arrive to 0 over 0, undefined by undefined, n over 0, we understand, or whether you have any constant, because n simply represents any of the constants. So in that case, it's better we make use of L'Hospital rule, right? And what L'Hospital rule is basically saying is that if you are asked to find the limit of a function, like we are asked to find the limit of function, let me simply say x tends to maybe 0 or anything. X can be anything, you understand? It can tend to anything, right? Let me simply say x tends to a here in the case of constant value. So let's go ahead and say we are going to have of f of x divided by what? G of x, right? And I'm asked to find the limit using L'Hospital rule. That basically means I'm going to basically say I'm going to find what? Derivative, right? I'm going to have f prime of what? Of x divided by what? G of what? G prime of what? Of x. Can you see it? And then I cannot go ahead and substitute the value of what? Of whatever I'm having. So in that case, I have to have the knowledge of what? Of differentiation, so that I can be able to differentiate the numerator and also the denominator, because the derivative of what? Of f of x here is actually what? F prime of what? Of x, and the derivative of what? Of g of x here is actually what? G prime of what? Of x. So I have to have the knowledge of what? Of differentiation for me to what? To be able to use L'Hospital rule. And whenever I'm using L'Hospital rule, it basically means I'm having an undefined function. You understand? That is, I'm having something like this, the case of 0 over 0, undefined divided by undefined, or any constant divided by 0. So in that case, the limit of that function is what? Is not defined. So let's go ahead and see different question that we actually have under L'Hospital rule. So let's take a look at the first question I'm having here. I'm asked to find the limit of a function 2x to the power of 3 minus 4x plus 1 divided by x squared plus 5x using L'Hospital rule. So what it basically means, is that this function that you are seeing here, right, is basically, let me write as in this form. We are going to have f of x, right, divided by what? G of x. And in that case, my f of x simply represents 2s squared, right, 2s cubed, rather, raised to the power of 3 minus 4x, right, then plus 1. While my g of x actually represents, here is actually going to be s squared plus what? Plus 5x. That's what we have. So what I'm going to do in this kind of situation is to go ahead and what? And find the derivative of f of x and g of x. So I'm going to have f prime of what? Of x, which is also divided by the x, is going to be, here I'm going to bring down the 3. I'm going to have 3 multiplied by what? 2x power what? Of 2. And then let me just say something here. If you don't understand how to differentiate a function, kindly pause this video and go and watch my basic explanation on let me simply say differentiations for beginners. You are going to find out that you are going to understand fully well how to differentiate a function. It's actually very, very simple. So I'm going to bring down the 3, multiply by 2x power of what? Of 2, then minus 1 multiply by what? 4, right? Then I'm going to have plus 0. If I'm finding the derivative of constants, it's going to be what? 0. And if I'm finding the derivative of 4x, is going to be what? Constant value. And if I find the derivative of 2x power of 3, I'm going to bring down the 3, and this is going to reduce by a factor of 1, and that's going to be 2. So simplifying this further, I'm going to have f prime of x to be equal 6s squared, right, then minus 4. That's what I'm going to have. Then for the g of x, right, for the g of x, what I'm going to have for g of x is going to be equal 2x, right, then plus 5. That's what I'm going to have for g of x. So I can now go ahead and put the value here. So that shows that this implies that f prime of what? Of x divided by what? G prime of what? Of x is going to be equal, I'm going to have to be 6s squared minus 4, right, then divided by what? 2x plus 5. That's what I'm going to have. Then can I go ahead and take the limits of this function that you are seeing here, this derivative function that you are seeing here. So I'm going to take the limits. I'm going to have limit x tends to 0, right, of here is going to be 6x squared minus 4, right, divided by what, 2x plus what, plus 5. So if I go ahead and take the limit, I'm going to have this to be equal 6 into bracket 0 squared, right, then minus 4. Then I'm going to have divided by what, 2 into bracket 0, right, plus 5. So let's see what we're going to have. So in this case, obviously, listen, what I'm going to have here, we have minus 4. Then let's go ahead and see what's happening here. So here we're going to have this to be equal minus 4 divided by what, 5. So that's basically what the limit of this function. Because what's actually happening here is just that I'm going to differentiate with the numerator and the denominator. Then I'm going to use direct substitution directly on the derivative of the function. So after finding the derivative of this function, we have it was 6x squared minus 4, and that of x squared plus 5x, we have it to be what, 2x plus what, 5. So if I go ahead and substitute value here, I'm going to have the answer to be minus 4 divided by what, 5. That's the answer. Now let's go ahead and solve another question. We are asked to find the limit x approaches 1 of x raised to the power of 3 minus 1 divided by x squared minus 1. Now what happened is that we need to use direct substitution first. You understand? Because we have to check if there is an existence of a limit for this value here that we're having. Although I did not do that for the first question, I just like kind of use the first question to explain what L'Hospital rule is all about. But now this is a proper way of solving or finding limits of any function using what L'Hospital rule. The first thing that you actually have to do is actually to make sort of direct substitution to check if there is an existence of a limit for the function. Now let's go ahead and do that using direct substitution, using direct sub, that's dx. Then what I'm going to have here in this case, I'm going to have it to be, we're going to have 1 raised to the power of 3 minus 1 divided by what, 1 squared minus 1. And this is going to give us what, 1 minus 1 divided by what, 1 minus 1. That's basically what, 0 over 0, which is undefined. Right, it basically means what the limit of this function is what is undefined because I'm having 0 over 0. If you remember earlier, I said whenever we have 0 divided by what, 0, and then we have maybe any constant value over 0, or we have undefined over what, undefined, the limit will always be undefined. The limit is always undefined, and in this case it is undefined. Undefined simply means math error. Are you getting it down? So now let's go ahead and see what we are going to have if we make sort of L'Hospital rule. So using L'Hospital rule, let's see what we're going to have. We're going to have here, we're going to have, let me simply say, this basically function f of x, right? And this basically what function g of x, right? So what I'm going to do now is just go ahead and find f prime of what, of x, that is divided by what, by the x, or you simply say derivative of what, of the function. So here I'm going to have this to be what, 3x squared. That's what I'm going to have. And at the same time, if I go ahead and differentiate what g of x, I'm going to have to be 2x. So that's why the whole value here that I'm having, I'm going to write as what, as 3x squared divided by what, 2x. Right, that's what I'm going to have. So if I go ahead and use substitution method now, in this case, I'm going to have 3 into bracket 1, right, divided by what, 2 into bracket 1. So that's what I'm going to have, 3 divided by what, over 2. Then here, the limit is what is defined. Here is actually what, undefined. But here now is what it is defined. That's actually what L'Hospital rule is all about. That is whenever we are finding the limit of a function and then we arrive, the value that we get is actually what's undefined. That's a complete math error. We can go ahead and differentiate what the numerator and the denominator, right? Then to see what we are going to have. In that case, that basically tells you guys that L'Hospital rule is only limited to just a rational value, or let me say a rational function. Right? That's the only way we can actually apply L'Hospital rule. Whenever a value, or let me say a function, is not rational, in that case we cannot just go ahead and use L'Hospital rule, because it involves us differentiating the numerator and also the denominator before you go ahead and use. So now let's look at this question that we have here. We are going to use direct substitution. That's the first one, to check if there exists let me say a limit for this function. If there's an essence of limits for this function, we have using direct substitution here. So here we're going to have a raised to the power of 3 divided by what, a raised to the power of 3 divided by what, a minus a, and this is going to give us 0 divided by what, 0, and this basically means undefined. right? It is undefined because those have what any limits. So since there is no exist of a limit, or there is no extent of limits for this function using direct substitution, I cannot go ahead and make support of L'Hospital rule, because this particular function or expression resemble f of x, right, divided by what, g of x. And whenever I'm having that kind of function, I'm going to have f of x, or let me simply say f prime of what, of x, of the first one to be what, to be 3s squared. And this a raised power of 3 is actually what, a constant value, and that's going to be equal to what, 0. So divided by what, g of x, g prime of x rather, that is the derivative of what, of g of x, and this is going to give me 1 because a as well is a constant here. So that's going to be 0. If I find derivative of what, of constant, is going to be what, 0. You understand what I've seen now? And constant can be what, can be any value, any integer. Maybe it is 1, minus 1, they are constant. They will always give you what, 0. You understand? Whenever you find the derivative of what, of them. So now the next thing we're going to do is go ahead and what, and substitute the value of what, of a here. Right, so we are going to have, using what, substitution now, after we already what, find derivative, we are going to have this to be what, 3a squared, right, divided by what, 1, and the answer is going to be what, 3a squared. In my last video on defining the limit of a function using the factorization method. So I actually have what, I actually got 3a squared. So in this case as well, it's also what, 3a squared. So that's just it. Now let's check another question that we have. We are asked to find the limit x approaches a of x squared plus 4ax minus 5a squared divided by what, ax minus a. Now if you use direct substitution, using direct substitution method, right, using ds method, we're going to have this to be a squared, right, then minus 4a squared, right, then minus 5a squared. If I substitute all the value, or if I replace all x here with what, with a, that's what I'm going to have. So here we're going to have the next thing, I'm going to have this divided by what, a minus a. So that's that a minus, listen no, a minus 4a squared minus 5a squared. You understand? This is basically what I want you guys to what, take note of. This is actually what, plus rather. So this is going to give us what? This is going to give us 5a squared minus what, 5a squared, right, divided by what, a minus a, and that's basically what, 0 divided by what, 0. So in that case, the value, or let me say the limit of this function is what, is undefined, using what, using direct substitution method. Now let's go ahead and what, and basically what, differentiate. So we're going to have f prime what, of x to be equal 2x, right, plus what, 4a. That's what we're going to have, because this is a constant value and it's going to be equal to what, 0. Now this is going to be divided by what, g of x, or let me simply say g prime of what, of x. So here we're going to have it to what, to be 1. So using direct substitution on what, on this value here, we're going to have it to what, to be 2 into bracket what, a, right, then plus 4a divided by what, 1. And this is going to give us what, 6a. That's the answer, right? So that's just it about this video. I'm going to solve one more question and then we'll call it the end of what, L'Hospital rule. But the fact I want you guys to understand is that using L'Hospital rule, you are going to differentiate what, the denominator, and at the same time the what, the denominator, before you what, substitute. That's basically L'Hospital rule. And then make sure you check very well that, okay, make sure you check if there exists a limit for any particular function using direct substitution first. It is always very, very important to do that first. Then you cannot go ahead and what, and use L'Hospital rule if the limit is what, is undefined. Then apart from that, also know that L'Hospital rule is only limited to what, to the rational what, function. That is, you are having something rational, something division. You understand? That's basically what you can actually apply L'Hospital rule on. If you have something like, maybe we are asked to find what limit x approaches what, a, of what, of, let me say 3a x, right, plus what, 2x, 2s squared. In this case, this is not a rational function, right, and in that case you cannot apply what, L'Hospital rule. Do you get it down? So now let's solve one more question and then we call it the end of the video. This is going to be the last question. So here I'm going to use what, direct substitution, using ds method, right. So here I'm going to have it to be infinity squared, right, then minus 9 divided by what, infinity squared minus what, 3 in the bracket infinity plus what, 2. Now, do you know what infinity means? Infinity basically means large number. So if I'm having infinity squared, it is what, large number. Just like we are talking about 1 million squared is a very, very large number. Minus 9, it is still what, large number. So everything here is going to be giving infinity, right? Then divided by, here as well, infinity squared is a large number. Minus 3 infinity is still a large number. Then plus 2 is still what, a large number. So this is going to give me what, infinity. So in that case, infinity over infinity, this basically means using direct substitution, this is what is undefined. Right, this is undefined because I'm having infinity over infinity, and you know what the condition is. Whenever you have any constant over 0, it is what? It is undefined. Right, let me simply represent as what? As ud. Whenever you have infinity over what? Over infinity divided by infinity, that's what? Undefined. And at the same time, whenever you have the last one, which is actually 0 over 0, it's actually what? Undefined. It basically means math error. And in that case, since I'm having math error here, the next thing I'm going to do is just to go ahead and apply L'Hospital rule, since I can see that they actually what? A rational function. So here I'm going to have this to be what? F prime what? Of x, right? This is going to give us 2x, right? Then divided by what? G prime of what? Of x, and this is going to give me, this is going to be 2x, right? Then minus 3. So using direct substitution here, we're going to have what? We're going to have 2 multiplied by what? Multiplied by infinity, right? Look at this. So then divided by what? 2 into bracket what? Here is going to be infinity squared, right? We're going to have 2 into brackets infinity, right? Sorry, it's not infinity squared. Then minus what? 3. Now, if you look at this 0, if I still go ahead and apply the value here, right? If I apply it here, you know what you notice that I'm going to have what? I'm going to have infinity at the same time divided by what? Infinity. In that case, it is still what? Undefined. Then if I'm having this kind of situation, what is the best advice I can do here is that what I'm going to do now is that since I'm having the power of the numerator and the denominator to be exact the same thing, I can actually go ahead and let me simply say divide all three by what? By the power of what? Of x, by the highest power of what? Of x. If I divide all three by the highest power of what? Of x, I'm still going to have infinity, because honestly speaking, I'm going to be having 1 minus what? Minus 9 divided by what? S squared. That's what I'm going to have. Divided by what? I'm going to have here is going to be 1, then minus what? Minus 3 over what? Over x plus 2 over what? Over s squared. If I divide all three by the power of what? Of by the highest power of what? Of x here. So this is exactly what I'm going to have. It's still going to give me what? Infinity. Now in this kind of situation, what do you think I can do? What I'm going to do is that I will have to differentiate twice. I will have to differentiate what? Twice. That's basically what it means. That is, after finding what? The first derivative, I'll go ahead and find the second derivative, because after finding the first derivative, the value is still what? Undefined. Then the next thing I'm going to do is just to go ahead and find the second derivative. And finding the second derivative, that basically means I'm going to have f prime, right, of what? Of x. And f prime of x, what do you think is going to give me? That is basically 2x, right? This is basically that's going to give me, sorry, this is going to be, that's 2 actually. Then divided by what? Another one. If I find derivative, I'm going to have what? Here as well is going to give me 2, and 2 divided by 2 is actually what? 1, right? So that's basically what I'm going to have in this case. But let's just hope and let's just see, right? Since I'm having minus 3 here, I'm having 2 over what? Over 2x here. This minus 3 actually has to go away, so that I can actually what? Affect like avoid what? Undefined. So if I go ahead and differentiate twice, and I differentiate what? G prime of what? Of x again. Differentiating this guy here again is also what? 2. Differentiating this guy here again is also what? 2. And that's going to give me what? 1. And then to this kind of situation, to this kind of question, the trick is that whenever you come across any question and you can see that the coefficient of what? Of here is of this guy and this guy here is what? Is the same thing. That is the coefficient of what? Of the highest power of what? Of x on the numerator, and the denominator is what? Is the same. You can go ahead and say 1 divided by 1 is also going to give you what? 1. So that's basically what? 1. Right? So to any question whereby you can see that okay, all the coefficients are what? Of the highest power of x on both the numerator and the denominator is actually what? The same. You can go ahead and divide, and you're going to have it what? To be 1. So that's basically what it means, because after finding what? The first derivative, the value is still what? Undefined. Do you get it? So the next thing I can just go ahead and do is just what? Go ahead actually go ahead and differentiate once again. So differentiate once again simply means I'm going to have 2 divided by 2, and that's going to give me what? 1. So this is now a limit for this what? Function. So that's so that there exists a limit for the function x squared divided by what? 9 divided by what? X squared minus what? 3x plus what? Plus 2 at x tends what? To infinity, and the limit is actually what? 1. So that's basically what it means, and that's just about this video. If you enjoyed this video, don't forget to like, share and subscribe. It's very, very important. Kindly subscribe, please. So that's just it, and make sure you share my video to your friends. It's also very, very important. Thanks for watching.